All right. Learning target 3. Again, still review. In this case, we're solving equations involving exponents. So the first ones have actual exponential, or actually rational exponents in them. So what do you do? But you can't take the square root immediately. It's like if you said x squared, you take the square root, or x to the third, you take the cube root. But when it says 4 to the fifth, or 4/5, what do you do? And then also we'll be doing some examples where you have variables in the exponent, and we haven't learned how to get those out yet, so we're going to be using exponent rules to solve those. All right, so for the first ones, do not overthink this. It's a basic algebra problem. We want this to say y equals. So somehow I need to get rid of the 4/5 power. All right, so how can I make that y to the first power? Well, you can raise everything to the 5/4 power, right? 4/5 times 5/4 is 1. So you would have to raise 34 to the 5/4 power. And so you'd have to use your calculator. And you end up getting 82.1. That's all you gotta do. Don't overthink it. So on the second one, again, it's a basic algebra question. Don't overthink them. You need to get the x to 3/4 by itself first. So you need to subtract 5. That's 729. Well, how do I get rid of the 3/4 power? I don't multiply, but I raise it to the reciprocal power. So 4/3. So 3/4 times 4/3 is 1. So you have 729 to the 4/3 power. And that ends up being 6,561. Those should not be that difficult. Simply use the reciprocal. Now, the last examples, I have 3 in your note sheet, and then 2 I made up, 2 or 3 that I made up because we need to make sure we know what we're talking about. All right. If you have an exponent that has a variable in it, like here, in here, in here, right? We have to be able to solve these, and there is a way to do it with logarithms. We haven't talked about it, okay? So one of these ways is using exponent rules. If the bases are the same, well, then the exponents have to be the same. So since we have a base of 3 for both of these, then x plus 5 has to equal 8. If we solve that equation, we subtract 5, x equals 3. No problem. Well, I'm going to give you a lot of these examples, or a lot of these questions on a worksheet, and so what if the bases aren't the same? So in this case, I have 4 to the x minus 3 power equals 1,024. Well, 1,024 isn't 4 to some power, or is it? All the ones I give you today can be rewritten with the same base. So 1,024 is actually 4 to the 5th power. If you don't know that, you can go through and test it out in your calculator. You want them to be the same base, you want it to be 4 to the something. You have x minus 3 equals 5, because if the bases are the same, the exponents are the same. So x equals 8 after you add 3. Not so bad. All right, and the next one I have 2 to the x minus 8 equals 8 to the 4th. Well, I have exponents, but the bases aren't the same. But again, I can make 8 into 2 to some power. So I can change this to 2 to the 3rd power, but you can't lose the 4th power you already had. Don't lose those exponents. So it's really 2 to the 12th power after you use exponent rules. So you really have x minus 8 equals 12. If you add 8, you get x equals 20, right? Okay, those are pretty simple. On the worksheet, they're more complicated, right? This first one down here, not supposed to be a trick question. But if you have 5 to the 2x minus 3 power equals 1, well, that 1 has to be 5 to some power. So 5 to what power equals 1? You can't multiply by 1/5 because we're not talking about multiplying, we're talking about power. So this has to be 5 to the 0 power, right? 5 to the 0 power equals 1. So I just get 2x minus 3 equals 0. And then you solve a simple algebra question, and x equals 3/2. I don't think any of those have been that difficult. You just got to think about them a little bit. This last one, though, has a lot of stuff going on. There's some like this on your worksheet today for learning target 3. So I have 27 to some power divided by 81 to some power equals 9 to some power. Well, again, all the bases have to match. So in this case, all the bases need to be the same. So even though 81 is 9 squared, I can't change 27 into 9 to some power. So that's not going to work. I'm going to change all of these bases into what? 3s. So I have 3 to the third power. That's what 27 is. And I have 3x plus 4. Divided by 3 to the fourth power times negative 2x equals 3 to the second power to the sixth power. Now I've got to use exponent rules. I need to go back and multiply the exponents. So I have 3 to the 9x plus 12th power over 3 to the negative 8x power equals 3 to the 12th power. All right. Now we're dividing. We're dividing, we subtract the exponent. So I have 9x minus negative 8x. That's a double negative. So that's 17x plus 12 equals 3 to the 12th power. Well, now the bases are the same, so it's a basic algebra problem. Okay? That's learning target 3. That's all it is solving these types of equations. There's an assignment from your book, and there's a worksheet. Make sure you do both. But hopefully you're saying this first half of this unit is just a good review of information. If you have questions, please ask me.